Hello students, welcome to EPG Pathshala. I am Dr. Prasanna Kumar Patra from Utkal University, Bhubaneswar. Today we will discuss about the module Methods of Studying Human Growth from the paper Human Growth, Development and Nutrition. Let us see what we are going to learn from this module. This module will focus on different methods employed in studying growth pattern among population groups. It will elaborate on the advantages and disadvantages of studying growth of children in all age groups, following cross-sectional, longitudinal, semi-longitudinal, linked longitudinal, and mixed longitudinal design. Child's net growth at a given point of time is a resultant of interaction between genetic and environmental factors. A child's growth rate reflects his state of health and nutrition better than any other single index. The average value of children's heights and weights reflect accurately the state of a nation's public health. The relevance of human oxyology as predictor of health status of individual as well as population as a whole has evolved considerably over the years. It involves concepts which are closely related to the process proper and precise methodology. For proper understanding of the concept like maximal growth may not be equal to optimal growth. Also, to explore if adult stature is a proxy measure for growth during childhood, relationship of disease and other growth affecting factors should be more rapidly demonstrated by directly relating growth parameters to later health outcomes. Hence, to understand aforesaid issues, it becomes imperative on the part of health professionals, oxyologists, anthropologists, and nutritionists to use precise methods of studying human growth to arrive at meaningful conclusions. Rather than merely quantifying the extent of change that occurs in different body parts of a growing child. During growth examination surveys, children investigators are more concerned with mean values and accompanying different measures of variability statistics pertaining to any of the body parameters measured amongst group of children rather than with the nature of growth pattern exhibited by them. Therefore, to obtain adequate set of age and sex-specific data to be used for comparative evolution, researchers most commonly adopt cross-sectional or longitudinal approach to carry out research in the field of human growth. In between a mixed longitudinal or semi-longitudinal or linked longitudinal method that represents short-term limited application of the longitudinal technique or an extension of cross-sectional approach is often employed. It talks about different methods of studying human growth. Those methods are cross-sectional method, longitudinal method, mixed longitudinal method, linked longitudinal method, and semi-longitudinal method. In this slide, you can see a group of children belonging to the same age group. They represent cross-sectional studies and how they represent, we can see in the next slide. A cross-sectional method of studying human growth involves measuring children only once during the entire tenure of the study. For example, in this method, a group of children being measured at 6 years of age would be altogether different from those who might have measured a year ago, or whom one might be proposing to measure later at the age of 7 years. Hence, in this method, there is no element of periodic assessment. Cross-sectional surveys provide information about distance growth attainments of different body parts of the children and reveal enough about the basic nature of the distance growth curve of any anthropometric parameter. In making cross-sectional standards, the numbers of children measured in each age group should be approximately proportional to the rate of which growth is taking place. Thus, about 3 times as many children should be measured in the first year after birth as at age 8 to 9 years. For example, put another way, the first year should be broken up into 3 periods, that is 0 to 0.32 years, 0.33 to 0.66 years, and 0.67 to 0.99 years, in age group of which same number of children should be measured as in the middle childhood year. The second year should be broken into 2 periods, that is 1 to 1.49 years and 1.50 to 1.99 year. Major standardizing studies sample about 1000 boys and 1000 girls in each age group, but half this number produces useful centiles. Samples of less than about 300 in each age group are unsuitable as cross-sectional standardizing series. Let's discuss about the advantages of cross-sectional method. This method of studying growth is cost-effective and less time-consuming, more easily controlled. It involves much larger number of subjects and provides good deal of information about distance attainment or gross size of children. For example, 10 kg of body weight and 76 centimeter of spine length at 1 year of age. This method is a rapid way of assessing the magnitude of growth or nutritional deficits and other health problems prevailing amongst children, representing different communities at given point of time. In this method, large number of subjects could be measured in a brief duration. Thus, data generated through cross-sectional surveys are often considered as better representative of a population and may be used to establish cross-sectional growth standards. And the disadvantages are, owing to their basic inherent nature, cross-sectional studies have one chief drawback. They can never provide information about the differences in rate of growth, that is, growth velocity of different body parameter, as they remain devoid of periodic follow-ups of children. Actually, it is these differences which provide insight into the dynamics of growth of children known to be controlled by genetic, variety of environmental, nutritional, psychological, socio-cultural, and economic factors. Another limitation of cross-sectional data is it does not precisely reveal about timing of occurrence of some particular phases of growth of children, like the onset of juvenile growth spurt, adolescent and attainment of peak height velocity, etc. in clear terms, as cross-sectional studies do not involve repeat examination of children So, growth velocity related information obtained from such data misleads to arrive at faulty decisions. Therefore, it is a question computation of growth velocity of any body parameter should never be made from cross-sectionally gathered sets of data. The cross-sectional surveys, being one edge point specific in nature, reflects conditions only during one season of one particular year, thus provide limited opportunities to have complete insight into the process which affect growth or nutritional status of population of people and their lifestyle. Thus, to obtain such standards, we need a longitudinal study. This is a very interesting slide which shows different stages of human life, starting from infancy up to old age. Longitudinal method. In a longitudinal method of studying human growth, each child enrolled in the study is periodically measured for one or more body parameters at fixed time intervals throughout the study plan. For example, all children measured at age 6 years will remain as the same as those who were earlier examined at age 5 years. The constancy of sample size and strict adherence to stipulated periodicity at which children are to be followed up remain the prime requisites of this study. A growth study may be longitudinal for any number of years. It may extend postnatally from birth to even 20 plus years. However, in actual practice, because of variety of reasons, it may not be possible to measure same group of children over a prolonged duration of time. To obtain the simplest type of velocity standards, individuals have only to be measured twice. This is what was done in the large-scale London standardizing study of 1996-97 and the Cuban national study of 1972 to 74. More intensive longitudinal studies follow the children over longer periods. The investigator then has to fit a growth curve to the serial measurements of each individual. For many purposes, graphical fits are sufficient, but mathematical curves may also be employed. The major drawback of a comprehensive longitudinal study is the time it takes to complete and the relatively small number of subjects that can be followed. To overcome these problems, Eveleth and Tanner in 1976 suggested a good design of linked longitudinal studies that we will discuss in next slides. In this slide, the figure given shows the distance curve of growth of a son and some students, those who were the first to be studied longitudinally. The Count du Montbéliard of France measured the stature of his son every 6 months from the boy's birth in 1759 to his 18th birthday. These data are usually considered to constitute the first longitudinal study of human growth. This was